Hello everyone, in this video we're going to be solving an awesome geometry puzzle. A red semicircle with radius 2, a green quarter circle with radius 3, and a blue semicircle with radius r are inscribed in a rectangle. Find r. So at this point you may just pause the video and try this problem yourself first. Okay, let's get started. Now, what I'm going to do is I'm going to be making some connections. So let me go ahead and connect the centers here. Okay. And then I will be making another connection. Let me connect these. And then finally, we're going to be connecting those. All right, cool. Now, by making these connections, actually, I'm able to associate r with the other radii. Now, I know that the radii here is, and actually, I can make this a little thicker. There we go. So this is going to be r. This is going to be a 3 and a 3, and this is going to be a 2, a 2, and a 2. Okay, awesome. So what I have is, I can actually find one of the legs here, since I know the hypotenuse and this. So let's call this one x. X squared plus 4 is going to be 5 squared, which is 25. From here, I get x squared equals 21, and x equals the square root of 21. Awesome. Now, x is equal to this length plus this length. And using the Pythagorean theorems, again, we can find those lengths, right? So let's go ahead and call this a, and let's call this one b. So what I can do is I can find the a and b. This is a 2, and the whole thing is a 4 here, since this is the diameter of the red semicircle. Awesome. So I can go ahead and write this relationship then. I can write a squared plus 4 is equal to r plus 2 squared. And that is equivalent to r squared plus 4r. And then I'll get a minus r plus r. It's going to be that. So now I can take the square root of both sides. And that should give me the square root of r squared plus 4r. So that's the value of a. Let's go ahead and find b. So b is going to be b squared plus 4 squared, which is 16, is going to be r plus 3 quantity squared. From here, you get b squared equals r squared plus 6r plus 9 minus 16 is going to give you a 7. Therefore, b is going to be the square root of r squared plus 6r minus 7. So I was able to find the values of a and b, and I can use the fact that a plus b is actually x, right? Because this is a rectangle. So what I can do is I can go ahead and add a and b and set it equal to, what I can do here is maybe change the color. Okay, here we go. A plus b, right, is going to be x, which is square root of 21. Awesome. So what we're going to do here is we're going to be squaring both sides of this expression and work it from there. Let's go ahead and do that. So if I square both sides, then I'll be getting something nice. Not nice at first, but then it'll become nicer. Okay, so we're going to be squaring the first term. Then I can square the second term, right? And then I can just write plus 2ab. That's going to be the product of these two things. So I can just go ahead and distribute that, right? So it's going to be r squared times r squared is going to be r to the 4th. Then I'll be getting 6r cubed minus 7r squared. Then I can distribute to 4r cubed, plus 24r squared minus 28r. Okay, awesome. This is my radical expression, and the whole thing is going to equal 21. Great. So let's go ahead and simplify this. This is going to give me 2r squared plus 10r minus 7 plus 2 times the quantity, r to the 4th. So I get 10r cubed, right? Negative 7 plus 24, that's going to give me 17r squared minus 28r. And this sum is equal to 21. Beautiful. Now what I'm going to do is I would like to subtract this from 21 and then isolate the radical term. Let's go ahead and do that. I'd like to simplify this more. So what I can do is I can subtract this everything from 21. So it's going to be like 21 minus this whole thing. And then I can simplify it. Okay, beautiful. So now let's go ahead and simplify this. This is going to be 21 plus 7, which is 28, minus 2r squared minus 10r. So, and then this expression is just going to be as is. But what I'm going to do is I'm going to square both sides because I want to get something simpler and I want to get rid of this radical. So let's go ahead and square both sides. At this point, if I do, I'll be getting something nicer, right? Okay, let's see what happens. I'll get 4 times the quantity r to the 4th plus 10r cubed plus 17r squared minus 28r, because everything will be, out of the radical. And this expression is going to be a little longer, but this is a plus b plus c squared. So if you just go ahead and square it, 28 squared is 784. Then I'll be squaring this term, which is 4r to the 4th. And then this will give me 100r squared. And then I'll be adding the 2ab, 2ac, and 2bc. So that's going to be minus 112r squared minus 560r plus 40r cubed. Awesome. Obviously, we can distribute this and make it better. 40r cubed plus 68r squared minus 112r. Don't worry about the numbers. They're going to get smaller when we simplify this. This is going to be 784 plus 4r to the 4th. Now I have 40r cubed. Notice that. And I have 100 minus 112, so that's going to be a negative 12r squared. And finally, I have minus 560r here. Okay, awesome. Now, what I can do with this? Well, the good thing is that a lot of these things are going to cancel out. So for example, not a lot of these, but at least the bigger ones. So these two terms cancel out, which is very nice. Then what I can do is I can go ahead and bring this negative 12 over here. That's going to give me 80r squared. Negative 560r, that's going to become positive. 560 minus 112 is going to be 448r. Okay? And then finally, our only constant, right, is going to be minus 784. Look how simpler this gets, right? Okay, awesome. We ended up with a quadratic equation. Beautiful. Now we can solve it, but the numbers are still way too large. So we're going to be looking for a common factor. Okay, so that's what we're going to do here. Let's go ahead and find a common factor. And common factor is going to be like what? Okay, looks like a lot of these, well, all these numbers are probably divisible by 4. I'm guessing, are they divisible by 8? This is like 400 plus, that's like 800 minus 16. Oh, that's cool. You know what? Actually, all of these numbers are divisible by 16. Why? Because this is, obviously 400 is divisible by 16, 48 is divisible by 16, 800 is divisible by 16, and 16, this is 800. Have you noticed that? This is 800 minus 16. So that means that this number is also divisible by 16. Beautiful. So then I can take out a 16 here. So then I'll be getting what? So this is going to be real simple. 5r squared. If you divide 448 by 16, think about it. Like 400 divided by 16 is equal to 25. 48 divided by 16 is 3. 25 plus 3 is 28. Beautiful. Okay. Minus. This is going to be, if you divide by 16, it's going to be 50 minus 1, which is going to be 49. Beautiful. Okay. Awesome. Now I get rid of the large numbers. Now I can solve this, hopefully. Now, we have a couple options here. You can try the X method and look for rational solutions. If we have rational solutions, they're going to come up. But if we don't, let's just use the Pythagorean theorem. Let's go ahead and use discriminant here. Negative b is going to be that. Okay. And then we're going to be getting plus minus the square root of b squared, which is 28 squared. Okay. Minus 4ac. So that's going to be minus plus 4 times 5 times 49. Awesome. So 49 and 28 are both divisible by 7. Have you noticed that? Now I got rid of the 16 here and divide by 2a, which is 10. Beautiful. So what I can do here is, actually both of these numbers contain 7 squared. So I can go ahead and take out a 7 here, right? And then inside, by the way, this is not delta, right? This is just x, r. Okay, I was going to write the discriminant, but I just ended up writing all the solutions. Okay, cool. So this is r. Now, what I can do is 7 squared. If I take out a 7 squared, you get 4 squared. This is 20. And this is already 7 squared, so it's done, right? Beautiful. So what I'm going to get from here is also going to be very nice, because you'll notice that 4 squared plus 20 is 36, and it's a perfect square. Perfect. Okay. So now I get 6 from here, and everything is awesome. Okay, let's see what we get. This is going to be negative 28 plus minus 42 divided by 10. Now I can split it up. Okay, and obviously we have a common factor of 2, right? We can just go ahead and, well, let's go ahead and simplify it first. Okay, fine. Obviously, one of the solutions is positive, one of the solutions is negative. I do not want the negative one because my R value cannot be negative, so we'll just discard it. Let's go ahead and simplify this. This expression is going to give us something nice because that's going to be 14 over 10. So that means that the radius we're looking for is 7 over 5. That's it. We found the radius, it's 1.4. I hope you enjoyed the video. Thank you for watching. Please comment, like, subscribe, interact in the comment section, and I'll see you in the next video. Until then, take care. Bye-bye.